Alright guys, so let's keep moving on with section 6.4 on solving equations that contain rational expressions. So far in the previous section 6.1 through 6.3, all we were doing is simplifying expressions, right? In this case, we are going to solve equations, which is a slightly different problem, right? So solving rational equations, well, so first of all, we are going to be given an equation, right, that contains rational expressions, right? That's how we can define a rational equation, right? And the following are the steps to solve those equations, right? We need number one to find the restricted values, right? As opposed to other equations, right? Like, for example, what we cover on chapter 2 during the first week of classes, right? We solve linear equations, right? Or first degree equations, right? And for those equations, we just solve them using all the steps that we know, all the techniques, right? And then at the end of chapter 5, we solve equations by factoring. Right, so in that case, we use all possible factoring techniques, just like factoring polynomials, grouping, trinomials, right? Differences of squares to get those solutions, right? To get the solution to those equations. However, for rational equations, so as we saw at the beginning of the chapter of chapter 6, these rational expressions, right, have restrictions, right? Again, let's recall what those restrictions are. Restrictions are those values, right? Let me highlight the denominator and observe the variable terms, right? Highlight the variable terms in the denominator and check for those values that make the denominator 0, because if we plug in, for example, in this case 8 over p, there is a number that we cannot substitute, right? We cannot plug in this case p cannot be 0, because otherwise, if p is a number 0, right, what happens to the denominator of the first fraction? Okay, let's find out. 8 divided by 0, and same for the second term, 1 divided by 4 times 0. That will give us 11 over 8. Okay, so the problem here is we get undefined. And we cannot plug in numbers, we cannot work with undefined terms, right? So p cannot be 0. Now, we need to observe all the denominators. So, okay, it would be a good idea to actually highlight all the denominators here, right? It would be a great idea. So, in order to find the LCD, we find out that, well, we have powers of p, right? We have powers of p on the one hand, and we also have numerical coefficients. Again, we go with the largest number, right? In this case, 8p. So 8p will be the quantity that once we distribute it on all terms on both sides of the equation, right, we get those denominators cancel. All right, in this case, we are going to use the least common denominator in a slightly different way as the way we did it when adding and subtracting fractions with different denominators. So back then, all right, we were multiplying by missing factors in order to obtain the same denominators. What are we going to do here? How are we going to use the least common denominator? Well, we're gonna do the following. So we will, okay, first of all, let me write the equation again. So in this case, we are going to multiply both sides by the LCD, which in this case is 8p, right? The next step is to distribute the LCD for each term. And again, I'm going to denote this using arrows just so you can see how are we doing the distribution, right? Okay, so on the next step, I'm going to keep the same colors again, the same way I was doing it on the previous videos, right? So 8 times the quantity 8p divided by p plus 1 that multiplies the quantity 8p divided by 4p. And then equal sign 11 that multiplies the quantity the quantity 8p, and then divide that by 8. Okay, so at this point we're good to go and divide out common factors. So notice we can cancel the p's right here, right? We can also cancel the p's right there. Over here, when we divide 8 by 4, we get a 1 and a 2, right? 8 goes into 4 2 times. And on the right-hand side of the equation, the 8's cancel. Okay, on the next step, let's write down what are we going to be left with. We get 8 times 8, which is the number 64. 1 times 2, right? The quantity 1 times 2, which is 2. And that equals to 11p. Okay. Combine like terms on the left-hand side of the equation. That will give us a 66 equals 11p. And then finally, divide both sides by the number 11 in order to get p by itself. And notice how the p's go away. All right. That means that p equals 66 divided by 11, which is 6. Okay, notice the last step listed over here, right? Okay, let's number 1 determine the restricted values, right? Determine the restricted values. That's what we did here, right? P. Let's actually put numbers with a different color. How about that, right? That's number 1. Okay. So number 1, find the restricted values. In this case, the equation cannot take the value of p equals 0. Okay, determine the LCD of the denominators. That's number 2, step number 2. Okay. Step number 3, multiply both sides. Okay, let's highlight every single step we already done. Okay, finding the LCD. Okay, we're going to multiply both sides by the LCD and then cancel out all denominators, right? So basically here, that's done pretty much right here, right? This is where we multiply both sides, every single term of both sides by the LCD, and divide out common factors. And then if we did the correct step correctly, right? And I mean the correct LCD, if we got the correct LCD, then the equation that we get will have no fractions left, right? Let's verify that. So that's number 4. Number 4, and notice no fractions at all. And that's because we did the correct LCD, right? That's why. So the next step, solve the equation, which is what we did, right? We solved the remaining equation, right? And we got p equals 6. Okay, so that's number 5. Solve the equation. And the very last step, verify for extraneous solutions. All right. What do we mean by extraneous solutions? Okay, let's write down a note here. Solutions that make the denominator 0. How do we know this? All right, how do we know those values that make the denominator 0? Compare. All right, let's compare our solutions. Compare this p not equal to 0 with p equals 6, right? In this case, the solution is not, okay, so the solution is not the restricted value. All right? Because in this case, the solution is not the restricted value. This is an okay solution, okay? So that is the solution to our first example in rational equations. All right, let's do a second example. Let's do another example. Let's see. We have the equation 3 divided by 2b minus 1 divided by 4 divided by 3b equals 4 divided by 3. Sorry about that. Okay. First of all, we need the restricted values. Okay. How do we find the restricted values? Okay. Let's first of all highlight the denominators, right? Highlight the first denominator and highlight the second denominator, right? We have two different denominators, right? So in this case, again, let's go back to what we did in section 6.1. In order to find the restricted values, set the denominator equal to 0 and solve the mini equations for the variable. In this case, we need to add add 1 to both sides to get 2b equals to 1, and then finally, in order to get b by itself, divide both sides by 2, and b equals 1/2. Okay, so b cannot be 1/2, nor cannot be, okay, what's the others? In this case, the other restricted value will be the number we get out of solving this other equation. In this case, b, 0 divided by 3, it's still 0. So b cannot be 0 either, right? Because otherwise, the denominator gets 0 for these two values, and then the equation will go undefined. All right. Let's find the LCD. The LCD will be the product of all the different denominators, right? So let's notice we have 2b minus 1 and 3b. So in this case, the product of the two will be the LCD, 3b times 2b minus 1. Okay, so that's what we're going to do here. I'm going to write the equation again, okay, and I'm going to need a little bit more of space here. I'm going to rewrite the equation. 3 divided by 2b minus 1 equals 4 over 3b. Okay, and then I'm going to multiply both sides by the LCD. 3b times b minus, oh no, not b, 2b minus 1. And on the other side as well, 3b times 2b minus 1. Okay, so in this case, let's distribute that LCD over the first term, and let's do the same on the right hand side, right? We do it on the left hand side first, and then we do it on the right hand side afterwards. All right, so let's say we get the following. We get, I'm gonna keep the same colors, right? We multiply the quantity 3 times the LCD, right? That is 3 times the LCD, right? I'm highlighting those quantities I'm going to multiply together. Okay, let's write that down. 3 times 3b times 2b minus 1. And then divide that by 2b minus 1 equals. Now on the right hand side of the equation, I'm going to distribute the 4 with the LCD 3 times 2b minus 1, right? So let's go ahead and do that, keeping the same colors, right? Keeping the same colors, we get 4 times 3b minus 1. No, not 3b minus 1, 3b that multiplies the quantity 2b minus 1. Sorry about that. Okay, and then divide that by the quantity 3b. Okay, so at this point, this is where we divide out common factors. Let's go ahead and do that. Let's look at the right hand side. Notice how the 2b minus 1 can be canceled with 2b minus 1. And on the other hand, on the other side of the equation, the 3 cancels the 3 and the b cancels the b. That will leave us on the right hand side with the quantity 3 times 3b, which is 9b. And on the right hand side will leave us with the quantity 4 times 2b minus 1. All right. The next step will be to distribute the 4 over the terms inside of the parentheses, leaving us the left hand side with the same 9b. It will give us 8b minus 4 times 1, which is 4. Okay, a good next step here would be to move the variable terms to the left hand side. Okay, so I'm going to subtract 8b. And the nice thing about this is, look how the 8b's go away. And on the left hand side, 9b minus 8b gives us b, only equals negative 4. And that's the final answer, right? That's the final answer to this equation. Now, let's go up a little bit here, right? Let's compare with the restricted values. The question is the quantity b minus 4 equal to any of the restricted values? B equals 1/2 or b equals 0. So in this case, the answer to the question is no. In this case, the solution to this equation will be negative 4 because it happens not to be the restricted values. Later, we are going to look at an example in which one of the solutions to the equation happens to be the restricted value. And in that case, we would call it an extraneous solution, which is what the series of steps on the previous page is asking us to do. Okay. Let's see. Let's look at the next example. Okay, the next example. Okay, that looks a little bit bigger, right? It's gonna be a little bit bigger example. Okay, number 1. In this case, let's observe all the denominators. Okay, let me highlight every single denominator: 3x minus 4 and 3x minus 12. Okay, if necessary. Okay, on the previous examples, we didn't see ourselves in the need of factoring denominators. This is the first example in which we will need to factor out greatest common factor, so that way we can find out what the least common denominator is. Okay, so 4/3 and 7 over x minus 4, I'm just going to rewrite them the way they are, right? Because there's nothing to factor out, right? Now, observe the denominator of the rational expression on the right-hand side of the equation, I mean the 3x minus 12, notice we can factor out a 3, leaving us with x minus 4. All right, so that's the equation that we're left with in the first step. Okay, now let's look for restricted values. Well, observe the variable factors in the denominator. The only one that we have is x minus 4. Okay, let's solve. Let's set it equal to 0, and it turns out x equals 4. So the restricted values, x cannot be 4, because if we plug in the number 4 for the second fraction, 7 over, for example, 7 over 4 minus 4, what's going to happen in the denominator? We get a 0, and that term will be undefined, right? We don't want that, right? We want to make sure that we don't have this undefined terms, okay? Now let's find the LCD. The LCD will be the product of all the different denominators, right? We take the highest power of each. In this case, we have the number 3 as one of the factors, and the quantity x minus 4. Now, in this case, I'm not going to multiply and divide by missing factors, because in this case, we are not simplifying an expression. We are solving an equation, right? So in order to move on to the next step will be to multiply both sides by the least common denominator to get the denominators canceled, right? And end up with an equation that doesn't have any fractions, right? Any denominators. Okay, so this is what I'm going to do. On the first step, okay, let me highlight what am I going to do. I'm going to multiply the quantity 3x minus 4 times 4, right? That's what I'm going to do. And I'm going to keep the same colors, 4 times the quantity 3x minus 4. Okay, and I'm going to divide that by 3 plus, okay, so that's distributing, right, the first one, and distributing over the second term, right, I'm going to multiply the quantity 3x minus 4 by 7, right, leaving us with 7 times the quantity 3x minus 4. Divide that by x minus 4. Okay, the next is the equal sign. So now we go with distributing the LCD over the right hand side. Keep in mind right here that there are invisible parentheses, right? So I'm going to do the following. I'm going to multiply the quantity x minus 1 times the quantity, the LCD, 3 times x minus 4, right? Essentially, I'm multiplying these two quantities here, all right? And then divide that by the denominator, which is 3 times x minus 4. Okay, what are we going to do next? The next step is to divide out common factors, okay? Notice the first term on the left-hand side of the equation, the 3's go away. Notice on the second term, the x minus 4 cancels the x minus 4. And on the right-hand side, notice how the 3's go away, the same way x minus 4's go away. Okay, the next step is to write down whatever we were left with on every single term in the equation. So 4 times x minus 4. Again, don't do that in your head. First, write down whatever you were left with, and then use the distributive property. And then 7 times 3, which is 21, equals the quantity x minus 1. And notice this equation, right? Notice this equation has no denominators. right? No denominators, and that's because we found the correct least common denominator, right? If for some reason on this step you still get denominators, most likely you did a mistake on distributing the least common denominator, or most likely you found the incorrect least common denominator. So it would be a good idea to double check on those steps, okay? Now, let's move on to solving this equation. So we need to get rid of these parentheses, and we get that by distributing the 4, right? Distributing the 4, we get 4x minus 16 plus 21 equals x minus 1. Now let's combine like terms. Let's combine like terms in on the left hand side. So 21 minus 16, that'll give us positive 5 equals x minus 1. Okay. Now let's have all numbers on the right hand side and all the variable terms on the left hand side. We accomplish that by subtracting 5 to both sides, giving us 4x equals negative 1 minus 5, that's x minus 6. And then let's subtract x on both sides, giving us a 3x on the left hand side and a negative 6 on the right hand side. Finally, the very last step to get this equation solved would be to divide both sides by 3, giving us x equals the quantity negative 6 divided by 3, that will be negative 2. Okay, now let's compare this x equals negative 2 with the restricted values, right? So the number negative 2, okay, let's highlight them. Okay, we highlight with blue, actually green, so there is a contrast. Okay, x equals negative 2, compare it with x equals negative 4. So it turns out that the only restricted value is the number x equals 4, because x equals negative 2 doesn't form part of the restricted values, right? Then we call it a solution, right? So this is an okay solution. Otherwise, if for some reason we get x equals 4, well, in this case, we don't have a solution to the equation. All right, let's look at another example. Let's see. Letter D, 5 divided by x plus 2 plus 3 divided by x minus 2 equals 1. All right, in this case, our first step would be to determine whether we can factor out the denominators, right? And then once we factor the denominators, we look for the number 1, the restricted values, and the least common denominator. But in this case, we can see there's nothing we can factor out in the denominator. Let's highlight in the denominator of the first fraction, which happens to be x plus 2. Likewise, in the denominator of the second fraction, which is x minus 2, there's nothing else to factor out either, right? So let's see, to find the restricted values, we set each denominator equal to 0 and solve the baby equations for the variable. In this case, x equals negative 2 and x equals 2. All right, so those are the two restricted values. Okay, let's go back. Let's go up here. X cannot be negative 2 and x cannot be positive 2, because if we plug in any of these values that I'm highlighting right here, that'll make the denominator equal 0, right? And we don't want denominators equal to 0, okay? So at the end of the solution to this equation, we are going to compare if any of the solutions happen to be one of these values. Hopefully not. All right, let's see. What would be the next step? Okay, the next step is to find the LCD, which in this case, the LCD happens to be the product of these two denominators, right? X plus 2 times x minus 2. Okay, I know what you're thinking. You may be thinking this is the factor form of a difference of squares, which incidentally is true. However, we are going to keep it in factor form in order to be able to divide out common factors. All right, we might need that difference of squares factor later in the solution of the equation, but in the meantime, let's keep it like this. Okay, so let's rewrite the equation. 5 over x plus 2 plus 3 over x minus 2. And keep something in mind, there is an invisible 1 right here, so this is 1 over 1. Okay, the next step will be to multiply both sides of the equation by the least common denominator, x plus 2, x minus 2, x plus 2, x minus 2. Okay, so let's distribute x plus 2 times x minus 2 with the first term, and that in order to get that done, okay, let me highlight we're multiplying x plus 2 times x minus 2 by 5. Okay, I'm multiplying those two terms. Let's go ahead and do that. 5 times, again, I'm going to keep the color just so you can see where is every single factor coming from. And then divide that by x plus 2. Plus, okay, let's distribute this over the second term, okay? In this case, I'm multiplying x plus 2 times x minus 2 by 3. I'm multiplying those two terms, those two factors I just highlight in blue. Okay, let me get rid of the highlights. And let's do the distribution. That's 3 times x plus 2 times x minus 2. And then divide that by the quantity x minus 2 equals to, okay, let's go to the right hand side. We'll multiply both factors with the number 1 in the denominator. But this is like multiplying only 1 by 1. 1 divided by 1, that's the same as multiplying by 1. So in this case, I'm not going to write it down. Okay, I'm just going to keep it. Well, actually, I'm going to write them down. I'm going to write it down just for visual purposes. X plus 2 times x minus 2. And then divide that by 1. Okay, so that's the step in which we distribute the LTD over the numerator of every single rational expression, right, in the equation. So let's keep moving on. At this point, we're good to go and divide out common factors. Notice the first on the first term of the left hand side, x plus 2 goes away with x plus 2. On the second term, x minus 2 with x minus 2. And then x plus 2 times x plus 2. Notice nothing cancel other than the 1s, but I mean multiply by 1, divide by 1 afterwards. It's the same as just keeping the same quantity, okay? So we're going to be left with the following. We are going to be left with 5 times x minus 2 for the first term. Those are the two terms that survive, plus 3 times x plus 2. Equals to the quantity x plus 2 times x minus 2. All right, so at this point, notice no denominators remain in the equation, and that's actually the main purpose of finding the correct least common denominator, to turn an ugly looking equation, an equation that has denominators, into a nicer looking equation that is an equation that no longer has denominators, right? So the next step would be to multiply this, right, to use this distributive property to multiply 5x minus 10 and 3 times x, that's 3x, divided and multiplied by 2, that's going to give us 3x plus 6. And that'll be equal to, notice this is a difference of squares, right, on the right hand side. This is of the form a minus a plus b times a minus b. right? Which all we do is square the first guy minus square the second guy, right? In this case, we are going to have x squared minus 4. Okay, let's keep moving on to solving this equation. All right, so let's combine like terms. We're going to have 5x plus 3x. Okay, let's highlight with green. X's with x's, so that's going to give us 8x, and constant terms with constant terms, that is negative 10 plus 6, that will give us a negative 4. X squared minus 4. All right. Okay, notice the difference of the equation that we obtain at this point as opposed or in comparison with the other examples that we did before. Notice we are going to end up with a quadratic equation. The other examples A through C gave us just linear equations, right? In this case, we're going to get a different type of equations, a quadratic equation. So let's move everything to both sides to one. Let's have everything on one side of the equation. Notice how this 8x goes away and how this negative 4 with positive 4. All right, on the right hand side of the equation, notice how this negative 4 cancels this positive 4, leaving us with a 0 on the left hand side and x squared on the right hand side minus 8x. All right, the thing here is, notice we got the 0 on the left hand side. We can always move it or reverse the equation, so we have the 0 on the right hand side, right? Let me do that so you don't get confused about the 0 being on the left hand side. It is the same because I guess we get very used to having all the variables, or well, on an equation that is higher the first degree, we get all terms on the left hand side and the 0 on the right hand side. Next time, and we can factor out here when on the remaining equation, we can factor out, let's see, having a little bit of trouble here. All right, we can factor out the greatest common factor. In this case, factor out an x times x minus 8. Using the zero product property, this tells us x equals 0 or x minus 8 equals to 0, or which is x equals to 8. So here we have two solutions, x equals 0, x equals 0, and x equals 8. Now, if we compare, if we go up here, the restricted values are negative 2 and positive 2, right? So in this case, none of our solutions happen to be that restricted value, so we're good to go in this case. This is a solution. This is also a solution, okay? All right, let's look at another example. Okay, let's see. Yes, for letter E, the left-hand side looks really big, all right? However, let's not worry about factoring the numerator. In fact, we don't care about numerators at this point, right? In this case, we're going to take care of the denominators only. And in fact, even if you try to factor the numerator, in this case you will try to find factors of 6 that add up to 8, but in this case there's none, because the only way to find factors of 6 is 3 times 2, and if we add them we get a 5, or 1 plus 6, and if we add them we get a 7. So there's no way we can find factors of 6 that add up to 8. So in that case, the polynomial in the numerator is prime, but ultimately, again, that's not what we care about. Okay, so let's Okay, let's erase this. So all we care is the denominator. So look at, let's highlight the denominators. So let's see. Let's see what's going on here. Having a little bit of trouble with my pen. Okay. Okay, let's see if we can find. All right, I'm having trouble here. Okay, let's see. Hopefully, okay, it works now. Okay, highlight the denominators only. Okay, let's factor out the denominators. So let's keep the same numerator. Let's keep the numerator, which is x. We leave some space for the LCD. X squared plus 8x plus 6 divided by, in this case, factors of -4 that add up to +3. Okay, the factors are x plus 4 and x minus 1, right? Typically on problems like this, right, notice something. Now, it is not always the case, but most of the times when we are given an equation like this, we're given a denominator in polynomial form, and then we're given individual factors on the other side of the equation. So typically this gives us a hint on how to factor this trinomial. It is not always the case, but in some cases I have found out that it is the case, right? And then this is 3 divided by x minus 1 minus 2 divided by x plus 4. Okay, so the next step will be to find the restricted values and the least common denominator. To find the restricted values, notice we have factors in the denominator of the form x plus 4. Set that equal to 0 and set the factor x minus 1 equal to 0. Solving for the first mini equation, we get x equals to -4. So the first restricted value, okay, so x cannot be equal to -4. On the other hand, x equals 1, so x cannot be 1. Because if you plug in -4, for the very last term, that's going to turn the denominator into 0, getting us undefined. If we plug in x equals to 1 on the first term on the right hand side, notice how we get a 1 minus 1, and the denominator gets equal to 0. Okay. So the LCD will be the product of the two factors, in this case x plus 4 and x minus 1, which is what we do on the following step. Multiply by the LCD. X plus 4, x minus 1. So the next step will be to distribute the two factors in the LCD by over the numerator term. Okay, be careful here. Keep in mind that this trinomial in the numerator has an invisible parenthesis set, right? So I'm going to keep the same colors again, right? So let's see. X squared plus 8x plus 6 times the quantity x plus 4 times x minus 1. The whole thing divided by the quantity x plus 4 divided by, times x minus 1 equals, let's do the same over here, distribute x plus 4 times x minus 1 with the numerator of the first fraction, right? So that'll give us a 3 times x plus 4 times x minus 1 divided by x minus 1 minus, let's distribute the LCD over the numerator of the second fraction on the left-hand side, giving us negative 2 times the quantity x plus 4 times x minus 1. Okay. And then the whole thing gets divided by the quantity x plus 4. Okay, at this point, now that we distributed the two factors of the LTD over every single term in the equation, we're good to go and divide out common factors. Notice how the x plus 4 cancels that x plus 4 on the left hand side, also x minus 1 with x minus 1. Looking at the first term on the right hand side of the equation, that factor x minus 1 with x minus 1 goes away. And the factor x plus 4 goes away on the second term of the right hand side of the equation. So at this point, let's write down whatever we were left with. So we were left with only x squared plus 8x plus 6 equals 3 times x plus 4 minus 2 times x, be careful here, x minus 1. Be careful with the signs when we distribute the coefficient. Distribute the 3, right? That'll give us 3x plus 12. And then when we distribute the negative 2, you need to be very, very careful with the signs because we're going to have negative 2x and then negative 2 times negative 1 will give us a 1. The left-hand side of the equation will remain the same. X squared plus 8x plus 6. Okay, now let's combine like terms on the right-hand side. 3x minus 2x. Let's highlight what we are combining. X's with x's. That's just x. And pure numbers with pure numbers, that's 12 and 1, that's plus 13. Okay. And keep the same on the left-hand side. Right? Let's keep solving this polynomial equation by subtracting x on both sides and by subtracting 13 on both sides. All right. So we get x squared plus 7x and 6 take away 13. Is that a negative 7? All right. Okay, let's see what's going on here. Looks like we are going to get a prime polynomial here. In this case, we are going to get a prime polynomial because it turns out that the polynomial that we obtain, okay, let me see if I didn't do a mistake. No, that's correct. All right, so this polynomial right here, x squared plus 7x minus 7. So there's no way we can find factors of negative 7 that add up to positive 7. So in this case, because the polynomial equation has no solution, then we call this a no solution. All right, so let's see. Why is that? Okay, let's write down why. Because the polynomial is prime. Okay, so that's why. All right, let's look at another example. All right, the following example has 1 to 3 terms again, right? Let's see. Okay, number one, let's write down all the denominators in factor form. Okay, so in this case, the first denominator, that is the denominator on the left-hand side, we have a difference of squares, which can be factored as 6 over z minus 1 times z plus 1 equals to 5 divided by z minus 1 minus 3 divided by z plus 1. Okay, so number one, the next step would be to find those restricted values, right? That is z plus 1 equal to 0 and or z minus 1 equal to 0. On the one hand, we're going to get z equals 1, and on the other hand, we get z negative 1 and z equals 1 on the second value. So the restricted values, or not x, so in this case, z cannot be negative 1 or z cannot be positive 1, because otherwise the denominators go to 0, giving us an undefined value. And undefined values is not what we want, right? So let's see. Let's find the LCD. The LCD will be the product of these two factors. The product of the factors z minus 1 and z plus 1, right? Because that's what we also have over here, right? On the right-hand side of the equation. So let's see. Let's write it down. Let's write that down. Z minus 1 times z plus 1. So multiply both sides by that least common denominator, right? So z minus 1, z plus 1, z minus 1, z plus 1. Okay, so let's distribute the LCD over the first term. Let's distribute the first term over the first term of the right-hand side and the second term of the left or the right-hand side. Again, I'm going to keep the same colors. What am I doing here? I'm multiplying the LCD by highlighted in green z minus 1 times z plus 1 with the number 6. Okay, so let's write it down. 6 times z minus 1 times z plus 1 divided by z minus 1 times z plus 1. On the right hand side of the equation, I'm going to multiply the factor z minus 1 times z plus 1 times the quantity 5, right? That is the numerator of the first fraction on the right hand side. Let's go ahead and do that. Again, I'm keeping the same colors just so you can see where is everything coming from. Z minus 1 times z plus 1. And then divide that by quantity z minus 1. Followed by minus. Now we do the distribution of the LCD z minus 1, z plus 1 times the number 3. Okay, let's go ahead and do that. So 3 that multiplies z minus 1 times z plus 1. Okay, that being divided by z plus 1. Okay, so at this point, let's divide out common factors. Notice the z minus 1 goes away, the z plus 1 goes away. On the left hand, everything goes away on the left hand side. Z minus 1 goes away on the first term of the right hand side, and z plus 1 goes away on the second term of the right hand side of the equation, leaving us with only the number 6 on the left hand side equals 5 times the quantity z plus 1 minus the quantity 3 times z minus 1. So notice again this equation that I'm highlighting right here, right? doesn't have any denominators, and that's because we used the correct least common denominator to divide out all denominators, right? So let's keep going and solve this equation. So we need to distribute the 5. So this is going to be 5z plus 5, and distribute the negative 3 over the second term with parentheses, right? Be careful when doing that. That's going to give us negative 3z plus 3, all right? The 6 on the left-hand side remains the same, right? Now let's see, what are we going to get? Combining like terms, let's combine variable terms with variable terms. That'll give us 5z minus 3c, that's going to give us a 2z, and constant terms with constant terms, 5 plus 3, which will be the number 8. The number 6 on the left hand side, sorry, that remains the same. Okay, let's see. Let's solve this equation for the variable z by subtracting 8 on both sides. All right, so that'll give us a 2z on the right, cancel the 8. And on the left hand side, 6 minus 8, that's going to be a negative 2. The very last step is to divide both sides by 2. And in this case, see what's going to happen this time. In this case, as a final answer, we're going to get z equals to negative 1. Okay, now I need you to observe this very, very carefully. In this case, yes, all the algebraic steps made sense, right? We didn't do any illegal cancellation, or we didn't make up any rules. However, it turns out that the solution we obtained here, z equals negative 1, happens to be one of the restricted values. Notice I'm highlighting them with purple. All right, actually, let me use a different color so a better contrast. Let me use yellow. Okay, so z equals to negative 1, c equals to negative 1, right? In this case, c equals to negative 1 turns out being 1 of the restricted values. So we cannot take this as an actual solution, right? So in this case, so the equation has no solution. No solution for this equation, right? Finally, something in which one of the potential solution turns out being the restricted value. Again, let's compare, right? So look at the quantities highlighted in yellow, which is our final solution, and the restricted value of z equals to negative 1, right? So in that case, no solution. Okay, let's look at one more. All right, so to solve the following equation, number 1, let's be sure to have all the denominators in factor form. All right, let's see. Observe the denominator. Let me highlight all the denominators. We have a 2x squared plus 3x minus 2, a 2x, and an x squared plus 2x. All right. Okay, so let's observe the denominator of the first term on the left-hand side. Notice the leading coefficient, it's not 1, right? So we cannot just find factors of -2 that add up to 3. So in this case, we're going to use the diamond method, right? Or if you want to use the guess and check method, go ahead and do that. I'm going to do the diamond method myself. I'm going to use the side of the page. You might want to use the back side of your page on your notes, on your handout. Okay, so let's see. I'm going to do the factorization of that 2x squared plus 3x minus 2. Okay, let me verify I did the correct. Okay, 2 plus 3 minus 2, correct. All right, and I'm going to use the diamond method for this. In order to get that, we multiply 2 times -2 to get a -2 and bring the middle coefficient. So in this case, we're going to look for factors of -2. No, not -2. Give me a second. It should be -4 at the top of the diamond. Okay, so look for factors of -4 that add up to +3. In this case, 4 and 1, and we want a positive sum. So let's make sure to give the negative sign to the smallest of them, right? So split the middle term into the sum of these two terms, of these two numbers that we obtained using the diamond method. So let me write it down again. 2x squared plus 4x minus x minus 2. And because we have 4 terms, use factor by grouping. Okay, so we need to find the GCF of the first group, which is 2x. Right, 2x, leaving us with x plus 2. And the GCF on the second group, notice there is a -1 as a GCF. And the final GCF, notice we have an x plus 2 and an x plus 2. And we can write this as 2x minus 1 times x plus 2. Okay, so that's the factor form of the denominator of the first fraction. Let me go back to the equation, 2x minus 1, x plus 2. Okay, so 2x minus 1 times x plus 2 will be the denominator of the first fraction. Okay. The denominator of the second fraction remains the same. That's just a 2x, right? Equals. We can factor something out in the denominator of the fraction on the right-hand side. There's a GCF of x, leaving us with an x times x plus 2. All right. Now, here is where we need to be very, very careful with the restricted values. So the number of restricted values this time will be not just 2, there will be 3 of them. So let's highlight all the different denominators. 2x minus 1, right? 2x minus 1 will give rise to the following mini equation, right? That will give us 2x equals 1 and then x equals 1/2, right? So x cannot be 1/2. Okay, let's find the second restricted value. The second restricted value will be coming from the factor of x plus 2. All right, so let's write that down. X plus 2 equals 0. X equals to -2. So x cannot be -2. And the third factor will come from the denominator of 2x right here, right? So factor 2x equals 0 means x equals 0. In other words, x cannot be 0. So in this case, we have 3 restricted values. Okay, let's find out what are we going to get for the LCD. By the way, the numerator of the first fraction should be an x, not just a 1. Okay, let me correct that. Okay, all right, we got it. Okay, the LCD will be the product of the 3 denominators, right? So in this case, the product between the quantity x plus 2 and the quantity 2x minus 1. However, notice there is a numerical factor of 2, so we include that in the least common denominator. So let's multiply both sides by the LCD, right? 2x times x plus 2 times 2x minus 1. 2x times x plus 2 times 2x minus 1. Okay, so the next step will be to distribute the LCD over every single term. So I'm gonna keep the same color as usual. I'm multiplying the quantity 2x times x plus 2 times 2x minus 1 by x. Okay, do not attempt to distribute anything. Keep it in factor form, because otherwise we wouldn't be able to divide out common factors. Okay, so I'm going to multiply the quantity x times 2x times x plus 2 times 2x minus 1, and then divide that by the quantity 2x minus 1 times x plus 2 minus, let's do the same, distribute the LCD over the numerator of the second fraction on the left hand side. So essentially we are multiplying the quantities 2x times x plus 2 times 2x minus 1 by 1. Okay, let me unhighlight. I'm going to keep the same colors. 1 times the quantity 2x times x plus 2, 2x minus 1, which divides, it gets divided by the quantity 2x. Okay, that equals, okay, let's do the distribution of the LCD over the numerator of the right hand side, right? The only one term on the right hand side. So essentially we are multiplying the number 3 with 2x, with the quantity 2x times x plus 2 times 2x minus 1. Okay, let's go ahead and do that. 3 times the quantity 2x times x plus 2 times 2x minus 1, the whole thing being divided by the quantity x times x plus 2. All right, so we're done with distributing the LCD over every single term, right, in the equation. So the next step will be to divide out common factors. And notice how a 2x minus 1 goes away with 2x minus 1. The x plus 2 divides out with x plus 2. Okay, I think that's about it for the first term. Let's look at the second term. For the second term, notice how the 2x cancels the 2x right here. All right. And that's about it, about canceling or dividing out common factors. On the term on the right hand side, the x plus 2 divides out the x plus 2, and then the x cancels the x right here. Now let's write down everything we were left with, right? So for the first term, we were left with some x times 2x, which gives us a 2x squared. All right, minus the quantity x plus 2 times 2x minus 1. All right, but in this case, notice we already did. This is the factor form of the polynomial in the denominator right here, right in the denominator of the first fraction given in the original. So we don't want to spend a lot of time foiling that. If you want to do that, of course, you're good to go. All right. And then equals to 3 times 2, which is 6, times the quantity 2x minus 1. Okay, so let's write down everything we are left with first of all. So 2x squared minus 2x squared, right? What was the answer to this? 2x squared plus 3x minus 2. But be careful with this negative sign, because this negative sign will affect everything inside, right? Notice we have a difference, right? And that affects everything. And then 6 times 2x will be 12x, and 6 times negative 1, that'll be negative 6. So 12x minus 6. Okay, the next step on this almost last step, we're getting done. We're getting somewhere here. Okay, let's distribute the negative sign. Again, distributing the negative sign changes the sign of everything inside of the parentheses. So 2x squared minus 2x squared minus 3x plus 2 equals 12x minus 6. All right, 12x minus 6. Yes, at the beginning the equation looked a little bit complicated, but notice something interesting here. The squared terms go away, and ultimately we are just going to have a first degree equation, a linear equation, right? No factoring at all, just moving the x's to the left and the constant terms to the right. So let me subtract 12x. To get, okay, we're running out of space here. Let me move to this part of the page. And so if when we subtract 12x from negative 3x, we get negative 15x plus 2 equals negative 4, and then subtract 2 from both sides. We get the following, negative 15x equals negative 6. All right, and finally, to get that x by itself, divide both sides by negative 15. Okay, see how the negative 15s go away, they divide out, leaving us with x equals, okay, negative over negative is going to be a positive, and notice this is 2 times 3, this is 5 times 3, cancel out the 3's, we get 2/5 as a final answer. And in this case, this 2/5 doesn't happen to be one of those restricted values which I highlight with green, right? See, x equals 1/2, x equals negative 2, x equals 0. Those are the 3 restricted values for this equation, and none of those are the ones that we obtain. So in this case, we call it a solution. Okay, this is the solution to the equation. Okay, all right. Looks like that's about it about this section. So let's quit for, and then we will move on to the following section, which will be solving rational equations and problem solving. Okay.